Let's talk about async await, Python's new syntax. So let's start by talking about Python. Python is a single process. It is, if you don't do anything special with the threading module, a single thread, and it is synchronous. It does one thing at a time as it goes. Now, that's normally just fine, and it makes understanding things very easy, but it becomes a bit of a problem when we talk about input and output. As we talked about in the performance lesson, network or disk access takes a lot of time. It's slow just because of the way the system works, right? You're talking over a network. The way the disk works and how long it takes to get data off of a disk just by the mechanical nature of what's going on is just slow compared to everything else that the computer is doing if you look at it just at like a CPU level or a memory level. Much slower. So when we think about how Python is synchronous, that means that it's going to make a call out to the network or out to the disk, and then it's going to do nothing until that data comes back to it. So it spends a whole lot of time just kind of sitting around and waiting for the data to come back, and that's really not great for us. So async await is a new syntax that was introduced to try and address that problem. The problem is, okay, Python does nothing while waiting for I/O. Is there some way that we could go ahead and use that dead time to get Python to do other things? And this is what async await allows us to do, is to sort of say, oh, well, while we're waiting for that request to come back, here are these other things that we could do in the meantime. We can continue to work. There is a caveat here, of course, which is that Python will only be able to continue to work on data that does not depend on the data from the I/O that is coming back, right? If you have serial requests and every request that comes afterwards depends on the previous request, well, async await isn't going to help you because you have to wait on the data that comes back to make the next one because it's dependent on it. But if you have independent processes, well, you can go ahead and say, oh, well, while we wait for this to come back, I'm going to go off and do this thing over here, and then I can come back when the data comes back either from disk or from network or wherever it's coming back to. For this reason, this is considered cooperative multitasking, right? When the request goes out, it can say, hey, I'm waiting on the request. I don't have anything to do. You take over, right? It's cooperative. It's fundamentally about scheduling the program, and the various logical pieces, whether they're functions or whatever it is, have to cooperate for this scheduling to work. And so fundamentally, async await is all about introducing easy cooperative multitasking into Python so that we can effectively, in some ways, circumvent the synchronous nature of it and speed up network and disk access. And you know what? That's perfect for a network application.
There's nothing quite like actually seeing it in action. So here we are in the terminal, and you notice that I have moved into a completely different branch for all of the material in Lesson 7. So we will be working off of the async class material branch. I also have been running in a virtual environment for the synchronous material, and for the moment I'm going to create a virtual environment on my end called Starlet. If you're using a different virtual environment tool like Venv or anything else that's available, this is going to look a little bit different for you, but this is just so I can have a completely different set of dependencies, and this will become relevant in the next lesson. For the moment, I'm simply trying to demonstrate the async await syntax in Python, and for that, I am going to change the directory into scripts, and in here, there should be two files, sync and async. And so we're going to mimic disk or network access, right? We're going to try and mimic something that takes a long time. Now let's start with the sync file, because that's going to be the easiest to understand. You can see that I have something really basic, where I have something that mimics I/O, and pretends to either be disk access or network I/O. And we simply say when we have started, and then we sleep for a second, and then we note when we have finished. Then we go ahead and we make sure we do this several times in a row. And by default, if we are running this from the command line, we run this from equals the top. I'm actually not sure what this is called. Dunder name equals dunder main. I'm also going ahead and simply setting a timer to really drive home the point of the difference between sync and async. So you'll see that I set a performance counter, and then I look at the time that has been elapsed, and we will note how long this takes to go. So I will note that some of the work that we are doing here is only going to work in Python 3.5 and above, I believe, but that there have been significant changes to the way async IO and all of the syntax works in both 3.6 and 3.7. So you can see that I'm running with the latest and the greatest at the time of this recording, and so we should be all set on that front. But if you are running an older version of Python, nothing that you see in Lesson 7 is going to work. So I would urge you to go straight for 3.7, honestly. Now let's actually go ahead and run sync. Now this makes a certain amount of sense, right? We ran a function 3 times, that takes a second. And again, we're pretending as if it's reaching out and then coming back. Now, for the benefit of shock effect, let's go ahead and see async. You can see that it ran in just 1 second. You'll notice that it ran start all at once and then finished. And given our understanding of async, this makes a whole lot of sense. We reach out to the disk or to the network and we say, okay, we need this thing. And then rather than waiting around for the data to come back, we say, oh, okay, well, we're waiting on something. Let's go ahead and do a whole bunch of other stuff in parallel. And so it becomes a question of scheduling. Now, we're running all in one process, all in one thread. So this really is a cooperative multitasking setting, as I mentioned. But of course, now that we've seen the results of the magic, let's peek under the hood and see what is going on. And so this is simply called async. This is very similar to the previous file. You will notice that here, instead of sleep, I am calling async IO sleep. And this is effectively what allows the cooperative part of the cooperative multitasking, right? If async IO knows that this is waiting, it can then hand off and schedule something else into the event loop, right? And so in main, instead of calling all 3 in serial, we're saying, oh yeah, well, we want async IO to be aware that we are trying to schedule all 3 of these at once, which is where we're mimicking this. And then main is more or less the same, with one fairly important difference. When you are calling an async function, it has to be within an event loop. It has to operate within something that is effectively going to allow the different pieces to schedule appropriately. What this means is that async functions have a little bit of a superpower. An async function can call another async function and can call synchronous functions, or what you might consider normal functions, a simple def function name, right? Not an async def function name as you are seeing here and here. However, because these asynchronous functions are meant to be run in an event loop, that means that a synchronous function cannot call an asynchronous function. You must always find somewhere to run the asynchronous functions within the loop. So that is going to be the big difference. Now, in a lot of places, in the context of specific libraries or frameworks, they will sometimes run the event loop for you. So they will obfuscate these details, and then it can feel a little bit like magic. And so by hopefully exposing a very short example here, you see that this really is just a slight change of syntax, and it is effectively a way of saying, no, these functions have to be run in a specific context so that I get the benefit of having a solution to the very particular problem that we described earlier in this sublesson.